Okay, so I mentioned it on Friday about our calculators only work common logs, so log space 10. So when we have a log that has a different base besides 10, we're going to have to be able to simplify it a different way. Okay, we can't use our calculators just yet. So what we're going to do is we're going to start with the first one, log of base 7 of 49, and we're going to figure out what that simplifies to be. So the very first thing we're going to do is we're going to make it equal to x. Okay, so we can make a little log equation. So go ahead and set it equal to x because we're trying to figure out what this thing simplifies to be. And then what we can do now is this is in log form, so we can take it to exponential, how we learned to do on Friday, and then we will be able to solve for x. So remember, we start with our base. Which one of those is my base? 7. So what we're going to do is we're going to take it to exponential. So it's going to be 7 to the x power equals 49. Now, some of these are relatively easy to look at and tell what x should be. However, some of them are not. Is it still wet? I just cleaned it. I was trying to get all the drawing stuff off of it. I didn't know there was still some bleach on it. Like I said, some of them are easy to look at. This one you can probably look at it and tell what x should be. However, some of them are not as easy. So what we're going to do is we're going to write both sides as the same base. So remember all of our powers, the squares and cubes and all that good stuff. So starting with the smaller number, can I rewrite 7 as any power, like a power of 2, a power of 3, a power of 4, anything like that, or is that as small as it goes? That's as small as it goes, right? But so then I'm going to look at the other side, 49. Can I write that as a power of 7 since 7 is on the other side? Yes, 49 is 7 to the what power? Okay. So what I'm going to do is rewrite it as 7 squared. The goal is to get the same base. Once you get the same base, then we can take and set our exponents equal. Okay, I have 7 to the x power equals 7 to the second power. So what I'm going to do is just drop the bases and set those exponents equal. And then I will solve whatever I need to solve. Is there anything that I need to solve here? No. So that's what my log simplifies to be, is 2. You don't have to write x equals 2. You could just write 2. Does that make a little bit of sense? Set it equal to x. Take it to exponential. We're going to rewrite both sides of it with the same base. Then we can drop the bases and set the exponents equal. So let's try 2. Got log base 9 of 3. And I want to figure out what that simplifies to be. So again, the very first thing we're going to do is set it equal to x. Once you have your log equation, then we can get it out of log form by taking it to exponential form. So 9 to the x power equals 3. So the goal, again, is to get the same base on both sides. Which one should I rewrite? The 9 or the 3? Sometimes you'll have to rewrite both of them, but a lot of the times you'll only have to rewrite one. What is 9 as a power of 3? 3 to the second power. Okay, so what I did was I rewrote the 9, but I keep that x the same. Now we got to think back to our exponents. What do I do with those two exponents? Do you remember? Power to a power, you multiply. So what is 2 times x? 2x, okay, equals 3. What is the exponent on the 3 that's on the right side of this equation? 1. Okay. Do we have the same bases now? So we can drop the bases and set our exponents equal. And then again, I need to solve for x if it's not already solved for x. What would I do? Divide by 2. And so x is going to equal, or this log is going to simplify to be 1/2. Think about it. 9 to the 1/2 power equals 3. Right? Make a little bit of sense? All right, try 3. Again, some of them are very easy to just look at and figure it out. Some of them are going to require just a little bit of work. None of them should be extremely difficult. Set it equal to x. Take it to exponential. Rewrite both sides with the same base. Once you have the same base, set your exponents equal and solve for x. So what you're going to do is, I always look at the bigger number. Can I write 64 as some power of 4? Meaning, is 64 like 4 to the second power, 4 to the third power, 4 to the fourth? Sure. Think about 4 times 4 is what? And then if I did it in one time, what would that be? Do 16 times 4. So 64 could be rewritten as 4 to the. We did 4 times 4, that gave me 16 times 4 more, so that's 4 to the power. Set it equal to x. Take it to exponential. And this one could technically be done a couple of different ways because 4 is a power of 1. 2, right? 2 squared. So I could technically rewrite it as 2 squared. However, if you just focus on the bigger number and ask yourself, is this bigger number a power of the smaller number? That way we don't have to change both. We can just change one if that is true. Is 64 a power of 4? Yeah, it's 4 to the what power? Third, okay. If it wasn't, then I would have to rewrite both of them, okay? But in this case, I can just rewrite 64 as 4 to the third. I now have the same bases. So I drop those bases and set the exponents equal. And this thing just simplifies to be 3. Is everybody okay with that? All right. I want you to try 4, but I'm just going to go ahead and tell you that on this one, you're going to have to rewrite both of them. Okay, you're going to have to rewrite both once you get it into exponential form. Does anybody think they want to look at those? I still have these charts that we made a long time ago. They want to look at these? Like how? So you're really looking to see, like, I was looking at the big number, and I was like, no, this is just a little. 9 is. So I always look at the big, rewrite the big numbers. If I set it equal to x, I take it to exponential. Again, you can always look at the bigger number and ask yourself, can you write that bigger number as a power of the smaller number? So in this case, can 27 be written as a power of 9? No. Okay, so that means I'm going to have to change them both. So what we need to figure out is what can 9 and 27 both be written as? If you look at your list, you see you have 9 and 27. 9 is under the squares, 27 is under the cubes. So look at the root. Those are both powers of what? 3. Okay, so what we're going to do is instead of 9, we're going to write it as 3 squared. Still equal to 9. It's just written in a different form. And then 27 is 3 to the what power? Third. Okay. Why did I not use parentheses on the 3 to the third? Because there's no other exponent there, okay? So there's no need to use parentheses. But on the left side, I did use parentheses because we now have to multiply those. So that's going to give me 3 to the 2x equals 3 to the third. Now my bases are the same, so I can just drop those bases and set the exponents equal to each other. And then what do I do to solve for x here? Divide by 2. And so x is going to be the fraction, 3 over 2. Okay, think about it. If you did 9 to the 3/2 power, think about simplifying those. We would take the square root of 9 and we would raise it to the third power. Square root of 9 is 3. And the third is 27, which is what it equals, right? All right, start number 5. Set it equal to x and take it to exponential. These fraction ones are the ones that usually tend to cause a little bit of an issue. Set it equal to x. And then we're going to take it to exponential. If my stuff will catch up. Taking it to exponential since my computer just froze. Does everybody go with that so far? Now here's the thing. With a fraction, we don't leave anything as a fraction when we're doing this. We need to get a whole number base, no fractions. So what I want you to think about first is how could I make this into a whole number? No, I can't divide it. I can rewrite it though.
2 over 1.
Kind of. If I switch it though, in order to move this 2 to the top, what would I have to make the exponent on it?
1 over.
I heard somebody say that. Negative, right? If this is a positive one down here, to move it to the top, couldn't I rewrite it like that? Doesn't that mean 1 over 2? Does that make a little bit of sense? All right, and then 16. What power of 2 is 16? 4. Stop right there to make sure everybody understands. Anytime you have a fraction, what you can do is move that denominator to the top by making the exponent negative. We're going to then multiply here. Negative 1 times x is just negative x. And now that we have the same bases, we can just take and drop the bases, set the exponents equal. And what would I need to do to solve here? Divide by negative, yeah. So this time x is going to equal negative 4. Okay, so that log is going to simplify to be negative 4. Everybody kind of okay with that? Sort of? Okay. All right, let's take a look at 6. This is also another one that tends to cause some issues. Set it equal to x, take it to exponential. That's the very first thing we want to do. Every time it says evaluate, that's what we do. Set it equal to x, take it to exponential. So I have 10 to the x power equals that decimal point 001. I got a whole number and I got a decimal. What's another way we can write a decimal? We can write it as a fraction. Okay, so let's think about this. What place value is that one in? That's the tens. That's the hundreds. That is the thousands. So what I'm going to do first is I'm going to rewrite that as 1 over 1,000. With the left side having a base of 10, it can't be broken down into 2 squared or 3 squared or anything like that, right? So what I need to think about is 1,000. Is 1,000 a power of 10? It is. Okay. Bring that 10 to the x. The first thing I'm going to do is rewrite that as 10. What is 1,000? 10 to what power? The third. Does that mean x is 3 here? I got to get rid of the fraction like we did the one that I just erased, like we did on number 5. We turned 1/2 into 2 to the negative 1. So if I do 1 over 10 to the third, what could that turn into? 10 to the negative 3. Do I have the same bases now? Okay, so then I can just drop the base, set the exponents equal, and solve if necessary, but there's nothing else to do, so x is going to be negative 3. Quick question. What base was that log? The original one? The base. 10. What did we say calculators work in? 10. So technically we could have done that one in the calculator, but we're learning the process, so we don't have to. Does everybody kind of get that one? So anytime you have a decimal 0.1, 0.01, 0.001, 0.0001, you're going to turn that into a fraction as a power of 10. Move that 10 to the top by making the exponent negative, and then go from there. All right, okay? I got one more for you. This one's a little tricky. This is one more that we just kind of have to think about versus being able to rewrite both sides. Think about it like this. You take it to exponential. 6 to what power equals 1? Anything to what power turns to 1? 0. So set it equal to x. Take it to exponential. Except for I didn't put it equal to x, did I? Try that one more time. Set it equal to x. Take it to exponential. And then again, there's not really a way to rewrite the bases. This is just one we have to remember. Anything to what power equals 1, that is 0. And here's a little trick. Anytime your argument is 1, no matter what the base is, that log is going to simplify to be what? 0, right? Okay, so just keep that in mind. If your argument is 1, no matter what that base is, that will always simplify to be 0. Any questions? Not too terrible, right? You just have to know your powers. Think about your numbers. 3 squared is 9. 3 to the third is 27. You're going to be using a lot of those numbers. Powers of 4, powers of 2, powers of 5. We won't get into extremely